Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 7th question from the St. Anne's Diocesan College Preliminary Exam, which was written in the year of 2023. And please guys, do expect a total number of 10 videos since the question paper had 10 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, we are told that a group of teenagers took part in a trial to test a new headache tablet. Okay, half of the group received the headache pill, and the other half received a sugar pill. Okay, of the group receiving the headache pill tablet, only 7 over 10 were cured, and then of the group receiving the sugar pill, 2 over 5 were cured. Represent the given information in a tree diagram. Indicate your diagram in the probability of each branch. Okay, so it's either a teenager guys takes a sugar pill, it's either a teenager takes a headache tablet or a sugar pill all together, and there's only half of them that will take a headache tablet, or half of them taking a sugar pill. And guys, in taking either one of these, there are only two possibilities. It's either you get cured or not cured. Are you together? It's either they get cured or not cured. For those who have taken a headache tablet, the chances of them getting cured is 70%, or 7 over 10. Are you together? 7 over 10 can be written as 0.7. That means 30% of them did not get cured. Are you together? And then for those who took a sugar pill, only 2 over 5 were cured, which is just 40%. That means 60% of them were not cured. Are you together? So the possible outcomes that we have over here, guys, you can take a headache pill and get cured, or you can take a headache pill and still do not get cured. Are you together? You can take a sugar pill and get cured, but you can also take a sugar pill and not get cured. Are you together? So the probabilities are over here. The probability of getting a headache pill and being cured is just 0.5 multiplied by 0.7. 0.5 multiplied by 0.7. This will just be equal to 7 over 20. And then over here, we have the probability of taking a sugar tablet and not getting cured. The chances are, that's just 0.5 multiplied by 0.3. You'll simply get 3 all over 20. And then over here, you'll simply have 0.5 multiplied by 0.4. The probability of taking a sugar pill and getting cured is just 0.5 multiplied by 0.4. This will basically be equal to 4 over 20. And then, is it 4 over 20? Let me check. 4 over 10 multiplied by 1 over 2. Yeah. And then over here, guys, the probability of taking a sugar pill and still not getting cure, you simply 0.5 multiplied by 0.6, and then your answer will just be equal to 6 over 20. if you add all of these probabilities, guys, you must get 1, because the sum of all probabilities in a sample space is just equal to 1. So this is how, guys, you're supposed to represent this information in a tree diagram. Okay, determine the probability as a percentage that a person chosen at random from the group will not be cured. Okay, the probability of not getting a cure, you'll simply take the probability of taking a headache tablet and not getting a cure plus the probability of taking a sugar pill and not getting cured. Are you together? And then those probabilities were 3 over 20 plus 6 over 20, and then our final answer will just be equal to 9 over 20. I believe this is just 45%. 9 divided by 20 multiplied by 100. Yeah. There is a 45% chance of not curing your headache. There's a 45% chance. Nah? Okay, now let's go to another question. We are told that events A and B are mutually exclusive, and then the probability of A is X, the probability of B is 2 times that of A, and then the probability of A and B is 0.72. So if ever, guys, we have 2 mutually exclusive events, if this is event A, that means that will be event B. Mutually exclusive event, guys, they do not intersect. Are you together? So the probability of A is X, the probability of B, it has to be 2 times X. Are you together? But the probability of A or B, since it is equal to 0.72, that means the probability of not A or B, or rather the complement of this guy over here, will simply be 1 minus 0.72. You'll simply get to 0.28. Are you together? So outside those 2 events, there is another chance of 0.28. Now they want us to calculate the probability of A into 2 decimal. Probability of A plus the probability of B is basically equal to the probability of A or B. Are you together? This statement is true because the 2 events are mutually exclusive. If the two events are mutually exclusive, that means the probability of A and B is just equal to 0. Okay, I know that the probability of A is X. The probability of B has to be 2X. This is just equal to 0.72. Then 3X is just equal to 0.72. And therefore X, which represents the probability of A, is just equal to 0.72 divided by 3. You'll simply get an answer of 0.24. 0.24. And then now we are being asked that are events A and B complementary? Justify your answer. They are not complementary, guys. They are not complementary. They are not complementary. The reason being is because the probability of A plus the probability of B is not equal to 1. If the sum of these 2 probabilities was equal to 1, then that means the 2 events were complementary. And then now we are told that events C and D are independent, such that the probability of C is equal to Y, the probability of D, is equal to Y plus 0.2, and the probability of the intersection is just 0.15. Determine the possible numerical value or values of Y. I know that the probability of C and D will be equal to the probability of C multiplied by the probability of D. This statement is true, guys, if and only if C and D are independent. In this case, we were told that these 2 events are independent. Are you together? So I'll simply have 0.15 being equal to the probability of C. That is just equal to Y multiplied by Y plus 0.2. I can change these decimals, guys, into fractions, right? 0.15 can be written as 3 over 20. This is y multiplied by y plus 1 over 5. Together, 0.2 can be written as 1 over 5. Then I can simply remove the brackets. I'll simply have 3 over 20 is equal to y squared plus y over 5. I can therefore try to remove the fractions by multiplying each and every term by the lowest common denominator. My lowest common denominator is 20. If I multiply each and every term by 20, I'll be left with 3 is equal to 20 y squared plus 4y. And then I'll have 20 y squared plus 4y minus 3 is equal to 0. I can therefore find the factors. That's 10y, 2y, 3 and 1, and then plus and minus. So therefore y is equal to 3 over 10, or y is just equal to negative 1 over 2, which is not applicable, guys. Why? Because probability of an event must always be between 0 and 1. Probability cannot be less than 0 or greater than 1. So this answer over here is not applicable. So y is just equal to 3 over 10, which is just 0.3. Okay, and then now they want us to determine the numerical value of the probability of the union of C and D. The probability of C or D is basically equal to the probability of C plus the probability of D minus the probability of C and D. Over here, guys, remember that the probability of C was just equal to y. So this is just 0.3 plus the probability of D is y plus 0.3 plus 0.2 rather. So I'll simply say 0.3 plus 0.2. This will just give me 0.5 minus the probability of the intersection. It was given to us as 0.15. So the final answer is basically 0.3 plus 0.5 minus 0.15. So I'll simply find an answer of 0.65. So this is the probability or the numerical value of the probability of the union of C and D. That's how, guys, we're supposed to tackle that question over there. So please do stay tuned and wait for more videos.